Hello, everyone. I'm going to show you, we're going to be learning, I'm going to show you what's called a TVM Solver today. It's a pretty fantastic tool to know how to use if you're working with finance situations or money situations. So a TVM Solver stands for time, value, and money. So it's basically a program that can do all the calculations to do with time and value and money. So that's what we're going to be using. So I have a link that works. I used to use these on a TI3 Texas Instruments graphing calculator back in the day. We don't really use those anymore because they're a little bit archaic, but the TVM solver works exactly like it. So it's pretty nice, handy tool. So let's get started. Before we get to the new part of the TVM solver, let's do a review activity. So press pause and give that a try. Figure out how much money needs to be invested now to grow to be $7,000 in 3 years if the interest rate is 9% per year, compounding weekly. Okay. So go ahead and press play, I guess, whatever. If you've pressed play, we're good to go now. So what you should end up with there would have been, you would have noticed, I'll add some work to this here, but we would have started saying, okay, we want to know how much money needs to be invested now. That's what we asked, right? And so notice that that's P equals, so that's the P we're looking for. Grows to be 7,000, that's your A in 3 years. So that's part of your N, but because we're compounding weekly, we have a 3 times a 52. And our interest rate is 9%. So our I is sort of 9%, but we're going to divide it into 52 tiny little pieces. Right? So there's those things all in the equation, and run the numbers. You do the 9 divided by 100 divided by 52 for this part. Gives you that number. Put that to the power of 156. Gives you this number here. And divide both sides by the 1.3096. Gives you a value of $5,344.90. Right? So that's the amount that if you invest it, this therefore statement here, therefore if you invested $5,344.90, it would grow to be worth $7,000 and so on. Okay? So we're going to do this question again with the TVM solver and see that it works. So let's learn what the TVM solver works, how it looks, and what the numbers are in it. So the N is very familiar here. It's the number of years, and later on we're going to write that as number of payments, but it's just your number of years. Your I is your interest rate, and you don't put it in as a percent. I have that wrong actually. Got to change that on the file. You're so used to putting it as a percent, of course, in work. So, actually, no, wait, hang on now. That's right. Not as a decimal is what I'm thinking, right? So Control Z here as a percent. So don't convert it to a decimal. That's actually correct the way it's written. Present value is your P, right? So that's your principal or your present value. Oh, we got a emergency alert going on. Oh, it's just a test. So the payment amount, well, we don't have payments in this situation, so we enter it as 0 if there aren't any regular payments, but we'll cover that soon. Future value is your amount, basically, right? That's your A. So you're familiar with it as A. Payments per year, well, you just put it as a 1, I think, if you don't have payments, and then if you have compounding periods per year, you'd put them in. Okay. So a thing to know about this program is that the value of the money, whether you put it in as positive or negative. And so you think of this, if you think of the TVM solver as a place where you're putting your money, then negatives are what you put in if you took money out and like put it into the TVM solver. It's kind of weird, but basically you have to have a sign convention or a sign naming strategy so that the computer inside can do the proper work. Okay, so basically you're taking money out of your account, putting it in the TVM solver. So people typically think of that number put in as a negative because you took it out, right? And then money you get back from the TVM solver and use, that's positive. So money that's coming to you from the investment. So think of the TVM solver as like an investment where you're putting money. Okay. The next page is just a summary of that stuff, but it's already been explained, so I'll just skip it. So since it's pretty quick and easy to run numbers, you can calculate, what the amount of a $5,000 investment would be after 10 years, easily. So let's do the amount for 6%. So $5,000 for 10 years at 6%. So let's go to the TVM Solver. On that thing yet or not? I don't know. Thought I did, but so up here in the file, there is a hot link that'll bring you to that. And here we go. Probably in the other kind of browser. All right, so let's go to this. We got a question here where we have $5,000, 10 years, 6%, and just compound annually. So $5,000. So $5,000 invested. Let's see here a little easier. $5,000 invested. We said it was 10%, I think. Check that. Yeah, 6%. Sorry, 10 years. That's what it was. So 6%, 10 years. So 6%. I just put it in as a 6 as a percent. Talking about 10 years, and we are compounding in this question just annually, and so our compounding periods per year is just 1. And so we can just solve for the future value. Okay, so boom, just solve. And I forgot showing you, it doesn't really matter because it just spits out the other sign anyways, but if I put this in as a negative, meaning I took $5,000 out and put it into the system, it's just going to give me the positive version. So it doesn't really matter. It matters more when you talk about payments. You have to have your payments be the opposite sign as your amount if you're borrowing money and so on. Yeah, so there's the number. So the 895424. So 895424 is the number that's in there. And then the nice thing about the program here, of course, is you can just be like, oh, what if it's 7%? And just boom, solve for a new number. So now it's 9835 and so on. It's literally just gives you the numbers instantly with a click of the mouse or click of however you're operating the program here. So each of these go to 8% and so on. Okay, you just solve. Gives you 10,794 and so on. Okay, numbers from the last time I did it. So if you just kept going, you'd have all these numbers just fill in by just clicking them over and over again. Okay, so notice that the increase here. The question is, does a 1% increase always have the same effect over this 10-year period? And notice that the increase was less than $1,000 at the start here. And then the increase is more than $1,000. So clearly the answer is no. And the question is, explain or why is that? And I hope it's obvious to you that it's because you have interest, get this more interest on interest thing going on, right? So compounding effect, interest on interest compounding effect, kind of, we haven't talked about it for a bit, so it's just basically a little review of that for you. Okay. So if we went back to this question here, $7,000, we want to grow to be that. We can easily do that even with the program, right? So we've got we want it to grow to be 7,000, so we want our future value to be 7,000. But just like we work backwards with the equations, we can work backwards with this program. Okay. So our question was, remind me here, 3 years, 9%. So 3 years here, 9% there. And what did we have for other info here? Compounding weekly. So I have to go in and make this be compounding weekly, which is 52. We don't have payment, so it's 0, and the payment per year can just stay as a 1. I think because payment's 0, you can put it again any number you want, but just 1, I guess. And we can solve for that principal value. Okay, so if we put in $5,344.90, it would grow to be $7,000. $5,344.90. You look back, $5,344.90 is the same numbers we calculated by hand. Well, it just builds confidence that the TVM Solver program is working. Okay, it works nicely for us. So now that we're gaining confidence, that let's see what else we can solve for. Right? We just solved for, in this one we solved for the principal, right? The present value. And this one we're going to solve for the interest rate. So we have an amount of $400 that's going to amount to $496 in 4 years. That means we have 400 to start with. Take out $400, put it in the TVM solver. I remember this time, and it grows to be 496. I think it was. Let me go back and check. So it grows to be 496 that you're going to take out of the TVM solver and put in your account, so that's a positive for you. In 4 years, we'll make that be a 4. And we're saying that this is how it grows, right? What do we have for compounding this one? You got to make sure to check all these details, right? So we have compounded quarterly. Well, back to the lesson about compounding periods. Quarterly means there's 4 per year. Now we can actually solve for what the interest rate would be. So solve for that number. So that would mean we would have 5.41% interest. Compounded quarterly would make this happen. Right? You can see the power of the program here. It's pretty slick. Okay, so there's your results here. I'll paste that in. And yeah, so basically the conclusion is have an interest rate of 5.41%, right? So therefore, blah, blah, blah. Interest rate should be 5.41%. Okay. Blah, blah, blah. So suppose interest is compounded annually instead of quarterly. Would a higher or lower interest rate be required to end up with that same amount of money? So just doing the video, guys. I'll finish up in a second. Make a prediction and figure it out. So if we had we're compounding annually instead, that's less often. And so you're going to need more interest, a higher interest rate, right? And then solve it, figure out. So if we change the compounding period per year to just be annually, double check my thought process here, right? I go annually instead of quarterly, then what interest rate would we need to have that same result? Well, we're going to solve, and it's probably going to be higher than 5.41%, right? So it's going to be 5.53. So as expected, higher. That's a win. Shows we understand what we're doing and using this stuff for. Right? So I think that's done. 1 second, please. And I think that's it there for that. And I do have one more. And I'm just doing, sorry, 1 sec. Yeah? I will be. Everything will be on Teams. Everything will be on Teams for you. Okay? So everybody thinks I'm talking to myself here, I think. So how long would it take $1,000 to double at 7% per year? We can solve for the number of years. So if we do $7,000, we want it to double. That means we can just make this be the 14,000. How long would it take to double if we have an interest rate of 7% compounded semi-annually? 7% compounded semi-annually. That'd be a 2. Okay, so we can just solve for how long. So we look and be like, oh, that would be about 10 years, basically. So that's what that is telling us there, that it takes 10 years. I have ran out of time for this lesson in school, in class coming in. If $5,000 was invested instead of, it was supposed to be $1,000 doubling. $1,000. It'd be interesting actually to see if that's the same thing. I think it should be. So it's supposed to be $1,000 doubling. Pretty sure this should be the same. So solve for that. It's not changing because it's the same thing. Right? Money doubles whether it's a big amount or a small amount if you have the same interest rate. Suppose $5,000 invested. With the doubling, actually I accomplished that by my mistake anyways. You're like, yes, it'd be the same. Okay, so good enough for now. I'm gonna sign off. So if you have any questions, of course, let me know. And of course, at the beginning here, up at the top, as usual, your practice questions. All right. Until next time, see you later.